So when we do number 3, let's go ahead and start by figuring out what the degree is. It is the 4th power because if we were to FOIL everything out, that would be a quadratic x squared, that would be a quadratic x squared, and if we did an x squared times an x squared, we get x to the 4th. So the degree is 4. Easiest way to do that is just add the exponents together, right? What are the x-intercepts? -3 and +4. And then what are the multiplicities of those x-intercepts? They're both 2. What does it mean since they have a multiplicity of 2? How's that going to affect the picture? Yeah, it's going to be like a mini parabola at that x-intercept. All right. Now, I do not want you to say this is -3, this is +4, and just write it like that. We need to put little markings so that we can count. So 1, 2, 3, 4. There's my -3. 1, 2, 3, 4. There's my 4. So the degree is an even number. Yes. X squared, squared, squared. So we have an even number for the degree. There is no negative sign in the front. So what does that mean? Positive. Goes up, up. Okay? So when you have an even number for the degree, the arrows either both go up or both go down. In this case, it's positive, so they both go up. Okay. So I know my end arrow goes up, my end arrow goes up. So when I draw for my x-intercept of -3, my multiplicity of 2, it can go above the curve or it can go below the curve. Which one makes more sense? Above. The -3 is saying that that's where I'm putting the x-intercept. It doesn't make a difference for if it goes up or down. So it goes up or down based on the context of where I'm at. It makes more sense for it to go up so it can connect to the arrow. Okay. All right, so for the other one, we have +4. It's a multiplicity of 2 again, so again, we can either go up or we can go down. Which one makes more sense? Up. So if we're going to connect to that arrow, it makes more sense to go up. Okay, and then when I connect those, I just do this, right? Just straight across, call it good? Yes. No. This looks like a piecewise function. Is it a piecewise function? No, that's why I can't do that. So these are polynomials. Polynomial functions have smooth curves to them, and so we have to make sure that when we connect it using a line that's a smooth curve. It does not matter if you make this really shallow, so if you went like this, that would be totally fine. The reason it doesn't matter is because we have no y values drawn. So one person can go really high, one person can go really low, and if somebody's like, those aren't the same graph, you just have to say, hey, I drew my y-axis stretched out more so than that person did. And you go, oh, they're the same. All right.
Like almost like you did half of the parabola and then you did a little more.
What do you mean?
On the side, like both of your orange and purple lines, like you have the first half and then the second half is like.
I just drew it because I know the part that was important was that it touched the x-intercept. The part in between I'm not sure about until I need to connect them. So I just drew, when I started, I said, I know that that x-intercept there's a parabola, so I connected it to the arrow because I knew it had to connect to the arrow. And then I knew it was a parabola. I didn't know what happened to the rest of the graph.
You kind of drew
I drew the parabola and I knew it had to connect to the arrow, but I didn't know what happened to the rest of the graph. And then when I was done, I had 2 parabolas that needed to connect to each other, and then I knew they had to have a smooth curve. So that's what told me the rest of it. Because the rest of it would be dependent on if there were x-intercepts in between, and maybe the x-intercepts in between did something interesting, and so I was just concerned with drawing that specific x-intercept, and then I wanted to add more detail later.
Okay.
All right, what is the degree for number 4? Degree of 5. Okay, what are the x-intercepts? 0 and 7. What's the multiplicity for the x-intercept of 0? 3. It is 0 because if it was 1, it'd say x minus 1 in the parentheses. So this one has no number with it, which is why it's 0. What's the multiplicity for 7? 2. Okay, so we've got 0. And then 7. So I'm always drawing those little markings. If you go by ones, I'm okay with you not labeling them. If you go by anything other than 1, then you need to write little numbers so I know how many you went by. You went by 5 or 10 or whatever. All right, so it's an odd number. That means the arrows go opposite directions. It's got a negative in the front, which means that overall it should have a negative slant like this. So what do the arrows do? What kind of arrows should we have? Yeah, it should be up first and then down second. So arrows up and then down. So I need an up arrow over here. I need a down arrow over there. Okay. So for this one, multiplicity of 3, again, I have 2 options. This is going to be harder for me to erase, so I'm going to draw it off to the side. So my 2 options are I can have the x-intercept and have the curve go through the x-intercept like that, or I can have the x-intercept and have the curve go through the x-intercept like that. And which way makes more sense if this is the point and the arrow is up over here? The second one. So what we're going to do is we're going to start right here actually. We're going to start up, we're going to come down, we're going to level out for a little bit, and then we're going to keep coming down. So I go down, I level out for a little bit through the point, and then I keep going down.
How did you figure out what you ought more
So it was a degree of 5. It had a negative in the front, and if it's got a negative in the front, I know overall it has to go down. So I put my pencil so it went down like that, and then I knew it was up arrow, down arrow.
And you knew that because it wasn't a parabola the first one? Is that why?
No, that's just me putting my arrows over here. When I drew for my multiplicity of 3, I drew my 2 options, and since my arrow's up on the left, the first option does not make sense. So I have to do the second option. Okay. The next one, we got multiplicity of 2. So we're going to have a parabola or a parabola. Which one makes more sense? The parabola. The top one or the bottom one? The bottom one. So I'm going to take this, I'm going to connect it to the arrow. And then what do I need to do with these 2? Smooth curve. Okay. Get rid of the top. My erasing marker does not like pencil. All right. Number 5. So I'm going to go ahead and write a 1, 1, 1. The multiplicities of 1 are typically not marked. We don't usually write an exponent of 1. We just, if there's no exponent, we assume that's a 1 there. So I'm going to put the exponent of 1s in, ladies. So what is our degree? Degree is 6. Okay. What are the x-intercepts? Okay. So 1, 2, 3, 4, 5, -5, -1, +2, +5. And we've got a multiplicity of 1, a multiplicity of 1, a multiplicity of 3, a multiplicity of 1. Now, it's a degree of 6, so what do we know about the arrows? Both up or both down, right? They have to agree. If we look at the front, what do we see? Negative. So Both down. Down. Okay, so down, down. What does a multiplicity of 1 look like? Linear. Go straight through. So that's pretty easy, right? We're just going to say there's the point. We got to go straight through the point. So I'm going to start at my arrow, and I'm just going to go straight through the point. Okay. -1 is also a multiplicity of 1. Does it make sense for me to go straight through the point like this? No, that would be a weird looking graph, right? So it needs to connect the blue part I already drew, but it has to connect in a way that makes sense. So I'm going to get rid of this part that I just did. And I'm going to say that it makes more sense to connect like that, and I'm going to make a smooth curve between the two. So some students get confused because they say, Ms. Rice, you just drew a parabola. That's a multiplicity of 1. But you have to ignore the fact that I made a parabola and just say, yeah, straight through, straight through. So I'm looking at what happened at the individual x-intercepts. Individual x-intercepts are a multiplicity of 1, straight through, straight through. Okay. What about the x-intercept of 2? What do we see there? Yeah, this snake, they call it an S-curve, even though it doesn't really look like this. So we've got 2 options. We can go up and level out and go up, or we can go down, level out and go down. And based on the orange, which one makes more sense? The left one. Okay. So I'm going to say, let's go up, level out, go up. And then when I connect it to my orange, I'm going to make sure it's a smooth curve right there. Yes. Because there's no gaps. And if I didn't draw it in different colors, then you would have not really had a thought about it. Yeah, so remind us again, what does continuous mean? You don't pick up your finger, you trace it, don't pick up your finger. So when we draw this graph, we're going to be able to trace it without picking up our finger, no problem, right? Okay, we got one last piece. It's a multiplicity of 1, so what do we do? Straight through, so I'm going to pick up where the purple one left off, and then just go straight through to that down arrow. Whew. Okay, last one. What is the degree? 9, 3, 3, 3, degree of 9. I made all of these a multiplicity of 3 because students hate drawing them. Multiplicity of 2, multiplicity of 1 are easy. Multiplicity of 3 looks weird, right? So we're going to practice multiplicity of 3. So we've got x-intercept of 0, -4, +2, all of them have a multiplicity of 3. So the reason that we're learning this is because we're kind of seeing how graphs work, where we can read graphs a little bit without a calculator, and that comes in handy in later advanced math classes where you're not allowed to use a calculator. So it might give you a picture of something, and then you could say, oh, based on the way the arrows are going, I can tell that that graph has a negative in the front. Or based on the way the highest exponent, I can tell that that should have, it's an exponent of 5, so it should have 5 solutions for x. Maybe they're not all different, but I know there should be 5 solutions. Or maybe it's written like this, and you can say, okay, I can get a general sketch for what the graph should look like, even if my sketch isn't perfectly accurate. So the benefit of this is that later on, we understand what different pieces of graphs are, so that we can use it to like make a situation more understandable when we don't have a calculator. Does that make sense? Okay, gotta make sure you text that to me. All right, degree of 9. So that's odd. What does that mean about the arrows? Yeah, 1 up, 1 down. Negative in the front. So negative graphs go like this. So what do the arrows do? Up, down. Up first, down second. Up, got up, and then we've got down. Okay. So first up, we have the x-intercept of -4. So is it going to be the left one or the right one? It has to be the right one. It has to be the right one because the up arrow is on the left, and this is the one that goes up on the left. So we're going to go down, level out, go down. Okay. At 0, we've got another multiplicity of 3. Is it the left one or the right one? No, it's the left one. So now we're going to go up, level out, go up. And then what do I do between these? Make it smooth. Okay. And then last, we have a multiplicity of 3 again. Is it the left one or the right one? The right one. So we're going to go down, level out, go down. Whew. Okay, how are your brains? Fried. All right, you probably want to leave these notes out. You probably don't want to put them in your binder because you're going to want to be able to reference the different options for multiplicities, and you're going to want to be able to reference the different options for the arrows to make sure you know that your arrows are going the correct way. Okay? Yes. All right, so let's go ahead and get the whiteboards out in front of us. Here is what we are going to do next. I'm going to give you a picture of a graph. You are going to write the equation on your whiteboard, and then you're going to hold it up. Sound reasonable? Don't go too fast. I don't have the answers written down. Okay, so I have to write these answers as we go. Okay, here is the first one. Shall we do them together to start with? Yes. Okay, so I'm going to write y equals, because if you don't have a y equals, you automatically get it wrong. Okay, so if I count these, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what should my first set of parentheses be? Okay, x plus 5 and, or not plus 5, plus 4. You're right. X plus 4, x plus 9, okay? Now, do those look like a multiplicity of 1, 2, or 3? So don't look at anything else, just look at what happens through the x-axis. 1. 1. So I see it bounce down here, but it doesn't matter unless it happens at the x-intercept. So straight through. Straight through.
How do you know if it's in a straight line?
It would have to literally look like this.
Oh, okay.
It doesn't. So the part that you're saying that's a parabola is not on the x-axis. That's why I'm not including it. Okay. And then we also have 1, 2, 3, 4. There's some symmetry here. 6, 7, 8, 9, 10. Okay, so what else do we need to include? X minus 4, x minus 9. Okay. The arrows both go up. What does that tell me?
It's even.
It's even and it's positive. So we have a multiplicity of 1, 1, 1, 1. Does that fit that the degree is even? Yes. And it's positive, which means we don't put a negative on the front. So this one's done. If you wrote that on your whiteboard, it would have been right. All right, let's do the next one. Okay. So I'm going to help you with this one too. Okay. So if we look at this one, we got this x-intercept right here. What does it do? Straight through. Okay, so y equals x plus 10, and it was a straight through. So that's a multiplicity of 1. What about this one over here? Straight through. What do I write for my parentheses? X minus 10. Okay, straight through. Now, we have an x-intercept of 0, so how do I write that? Just x. It goes in the front. And if I look at this, it does not go straight through. It's cubed. It squiggles as it goes through. Squiggles through. Okay, x cubed. Now, if I look at the arrows, I've got the left side goes up, the right side goes down. That's negative. That's a negative slant. So I need to put a negative in the front. We know that since the arrows are opposite directions, our exponent should be odd. Would our degree be odd on this problem? Yes. 3, 4, 5. Perfect. I was done. Does that make sense? Okay. Do you think you need to see another one, or do you think you could do one on your own? Try to do one on your own. Okay. So, you are going to write these on your whiteboards very big, because I am not wearing glasses that I should be. Okay? So, if you don't write it very big, I can't read it. Make sure you get the y equals. I'm not telling you that's right if your y equals is not there. You're welcome. Okay. I wish that I had Jeopardy music. You just write the equation. Yes. 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 Your 4 looks like a 1, but I got it. That is way too small, man. I need to wear glasses. Yes. 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 Signs. Your signs are opposite. You put the signs that are in the picture instead of the ones. Bigger font. Bigger font. Yes. Perfect. All right, so this is what we should have had. It squiggles through the -3, straight through the +4, straight through the +7. The arrows go opposite directions, and the slant is up if we think about the arrows, and so it's a positive graph. All right, here's the next one. Very close, but not quite. Very close, but not quite. No. No. So, you have to be careful. I think you got it, but your font is too small for me. Yes. Very close. Yes. Yes. Not quite. Not quite. You guys are so close. You're so close. Figure out what you get. Yes. Thank you. Very close. What? Where's the square? Did you put a square on an equal sign? No. I X minus 1. I'm not sure what's happening. Maybe fixed streamers? Almost. Yes. 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 You tell. Yes, I did. Yes. All right. So. Oh. Yes. Yes. Whew. Okay, so the common mistake was missing the negative in the front. Most of us got the rest, but we missed the negative in the front. So both arrows go down. That means it has to be negative in the front. And then x plus 4 cubed. Or sorry, x plus 4 squared. X plus 1 cubed. X minus 1. Yeah, it's a parabola. Alrighty. Ooh, this is a fun game. I like it. Alright, here's this one. Alright. Make sure you write it kind of big. You can go diagonal from corner to corner. That's big enough. Very close. Very close. Yes. You're a little bit off. Just a smidge. Yes. 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 Very close. Yes. Yes. No. You're very close to that. Yes. 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 All right. So we got a parabola, x plus 2 squared. We got a cubed. We got another parabola, it's just really wide. And then we got a straight through. Overall, it's positive because we got up arrow, up arrow. All right, here's another one. This graph is not nearly as pretty. You don't have to worry about it. You don't have to worry yourself. So there is a point there, but you don't worry. I only do x-intercepts. Yep, so even though you can see your y-intercept, you completely Yes. 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 No. Very close. Yes. 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 Why are you making fun of her? Yes. That's like you don't have to know that. Yes. Yeah, I do know what I know. Yes. Yes. But like it's like that. It's like all right, so we got an x plus 1 squared. We got an x minus 2 cubed. And then if we put a pencil you put a pencil going from arrow to arrow, we can see that slant up. You want to see the up slant? Marvelous. All right. Here's what I need from you. I think we've learned it. Have we learned it? We got to practice now. So clean off your whiteboard. Whiteboard's back up here. Marker's back up here. Paper towels go in the garbage.